So, well, ladies and gentlemen, everybody, let's give a huge round of applause as I welcome on the stage Mr. Dhruvik Shah. Everybody, let's give it up for him. And we are delivering the speech, the presentation on revolutionizing Q-commerce, engineering behind accurate delivery time at scale. Over to you, Dhruvik.
Hello. Yeah. Sorry. Good afternoon, everyone. I'm Dhruv Shah, working as an SD4 in Flipkart, and today we'll be discussing about how we are revolutionizing quick commerce, specifically about engineering behind how we are computing accurate delivery time for our customers. Right. Before going into the problem statement, let's raise the hand. How many of you have used Flipkart Minutes? Perfect. Great, right? So most of you know that Flipkart Minutes is a quick commerce offering by Flipkart. When we say quick commerce, let's go a bit deeper before moving to the problem statement. How a quick commerce is different compared to the traditional supply chain. Flipkart used to offer traditional supply chain, which means that any inventory is present across India, across multiple sources, and the customers across India would be able to order from those sources. That means that we would be able to cater across multiple locations, irrespective of the whether the inventory is lying near to the customer or not. While in quick commerce, how we solve the problem of delivering it fast to the customer is placing the inventory near to the customer, which means that there are dark stores which are located in the proximity of customer, and those dark stores are able to serve the customers only which are within those proximities. Right. So, and one other major difference is while there is a SLA of couple of days, right? It can go up to a few days. While in quick commerce, the SLAs can go up to few minutes only, right? So there are a lot of differences between traditional supply chain and the newer supply chain, which we had to solve. So let's go into the problem statements for them. Right. So the first problem statement is checking whether a customer is eligible or not. When we say customer eligibility, what does it mean? It means that a customer needs to be present near a particular dark store. We need to first identify whether a customer is present near the dark store or not. If it is present near the dark store, then only show the minutes tab, which we can see in the home page. Right. This is the first thing. Yeah. The next thing is whether can we map it to the correct dark store so that those particular inventories can be shown to the customer whenever the customer lands on the Flipkart Minutes app. Apart from this two problem statement, apart from identifying whether a customer is eligible for the Minutes app or not, we need to check whether a product is serviceable to the customer or not. So there are multiple aspects of serviceability. Apart from the exact delivery time computation, serviceability also includes whether a dark store is available, whether a supply chain, yeah, whether there are operational impacts due to which supply chain is not a dark store is not able to deliver the product, right? So there we need to first compute the serviceability, and then only the major concern of computing exact delivery time comes for the particular order, right? So let's go deeper into the first problem statement, which is eligibility of customers for minutes. Now, let's do some brainstorming, right? So let's say we have a problem statement, then there are a few dark stores. How do we systematically compute whether a customer is eligible for that dark store or not? The simplest solution would be I know that a rider can ride till 3 kilometers and it will be able to deliver in say next 15-20 minutes. So what I do is I just create a particular circle with radius of about 3 kilometers for across both the dark stores. Now, this would mean that any customer, let alone lying within this particular radius, would be serviceable from this dark store. Rest of the customers won't be serviceable from this dark store. Now, what are the problems with this? The first problem is for the customers which are lying across the edges, right? So let's say consider this particular scenario where half of the society is within 3 kilometer radius, but half of the society is not within 3 kilometer radius. This means that society is serviceable via a dark store, but half of the society is not serviceable via the dark store. And what it also means is that particular society might not be serviceable by any dark store because there is an entire area of no dark store or non-occupancy because of some local regions, right? So if we, by fixed radius, if we create the circle, we would face multiple problems pertaining to non-serviceability, right? So instead of going with the fixed radius, what we did was we created polygons. Yeah, so these are what we did was for each of the dark stores, we created a specific set of polygons, and these polygons are are on-ground representation of how much area a dark store can service. And these polygons are continuously updated as an based on the previous orders, based on how the riders are riding across the regions, right? So these polygons are created as whenever the dark store is onboarded and then updated in later stage of time. Now, let's so this identifying the area is solved. Now, next thing is how did we solve for the customer eligibility? So what we did was we use Lucene Spatial Library. What this library does is it provides us the indexing capability for spatial coordinates. So what we did was we index all the polygons into this library, and the library provides us the capability of given a let long, given a let long whether it is part of a polygon or not. So what does it mean is whenever a user comes to the homepage, we check whether whether that let long of the customer is lying in either of the polygon. If it is lying in either of the polygon, we give the dark store as a result. Dark store or the polygon. So polygon is mapped to a dark store. So from geospatial library, we are able to map to a polygon, and from that polygon, we are able to get the dark store. So this is the first step which we are able to solve within few milliseconds, given that this is a in-memory library, no network call is we need to make. So we are able to solve it within less than about 5 milliseconds, right? So this was the problem statement about eligibility of a customer. Now the eligibility has been done. The next step is serviceability of a product to the customer let long, right? So what are the aspects to that? So first aspect is whether a dark store is operational at that particular time, right? While few of the dark stores might be operational 24/7, few of the dark stores might be closed from say midnight 3 to 5, right? So we first need to check whether a dark store is operational or not. This is a static metadata for a dark store, so which we fetch it along with the dark store information, right? Post this, there is a stress factor for a dark store. When we say stress factor is something related to rider's availability to a dark store. This rider availability means a rider is whether a rider is present at a dark store to pick up any order. If not, where the riders are present, and if the rider is coming from any other delivery to a dark store, that means we need to add that time to our delivery time, right? And this would include the stress for further orders as well. So this is the first factor. And the second factor of serviceability obviously is the delivery time computation. We don't want our customers to, have very bad experience that they open the app and they see 1 hour delivery because of the rider unavailability, right? Or because of high traffic. So we have exact ETA computations and thresholds on top of that. If it goes beyond this, we would mark it as unserviceable, right? So let's go deeper into the ETA computation, which would cover all the 3 aspects. Right. Now the ETA computation. So first part is, as I mentioned, as part of ETA computation, first is rider availability, when the rider would be available at the dark store to pick up the order. Once the pickup has been done, what is the distance between the dark store to the customer location? And once the distance has been calculated, what is the current time taken to cover that distance by the delivery partner? So these are the 3 problem statements we have for ETA computation post the customer eligibility check has been done, right? Now go deeper into rider availability at the dark store. Now rider availability at the dark store has, what we do is we get rider info, we have a close tie-up with our logistic partners. What we do is from our logistic partners, we continuously sync the data of the on-ground orders which are being delivered right now, as well as the rider and the dark store information from the ground. So what we get, we get 4 types of information. One is active riders at the dark store, how many riders are currently available at the dark store, so that I am able to take exactly how many orders for that particular rider, which can be immediately picked up. If the active riders are not available, how many riders are en route to the dark store, which means that a rider can be far from the dark store, but en route to the dark store after delivering an order. So this adds to the SLA to our delivery time, right? Apart from the en route to the dark store, there are orders which might be pending at the dark store, which means that any new order I take, would be behind the queue, and it will add to the delay in the pickup of that order, because first the previous orders would be fulfilled, and then this order would be done, right? So there is a active orders pending at the dark store, and then there are orders which are yet to be delivered, which are engaged to the riders. That means the rider is not at the dark store, has not done the delivery, but the few orders are getting delivered currently to a customer. So it will overall add to the time of delivery. So all this information are periodically synced from our logistic partner per dark store and stored to our data store. Now, coming to the speed, right? As you know, right, in Bangalore, if you are riding in outer ring road, at midnight you will be reaching 2 kilometers in say 2 or 5 minutes, but 2 kilometers would take 30 minutes in peak time, right? So the average speed would differ at every point of time, but instead of for Flipkart, at the scale at which it operates, getting the traffic information on the flight is very expensive. It would incur very high latencies. So what we did was, we are computing the average speed of the riders for currently during the order placement or during the order fulfillment, right? So at every dark store, what we know is what is the current average speed for the riders for around that area. Given that dark store has a very low catchment area, the average speed would indicate the average speed around this area for that particular dark store. So instead of doing a traffic computation which is expensive, we stored the rider information along with the average speed for that particular rider, right? So this is how we solve for the rider ability. Next step is computing the distance. Now computing the distance, as you know, there are various it is a solved problem. Like, you use Google Maps, you pay them for the service, and it is a solved problem. But being cost efficient, we were not able to go to Google Maps, so we explored other options, and OpenStreetMaps were the obvious choice, right? OpenStreetMaps, along with Grasshopper, what it does is, we are able to provide accurate distance between two let longs, point A and point B. So in this case, point A would be dark store, point B would be the customer let long. What does this mean is, given a particular request, we call Grasshopper along with which is loaded along with OpenStreetMaps, and get the distance on the flight. Now this distance obviously would require a lot of Turing parameters. So Grasshopper itself provides many Turing parameters, including the vehicle type, including the turn. Including the turn weightage and everything, right? So based on those tuning parameters, we were able to get fairly accurate distance. And but the problem came when we were doing it on the fly. Doing it on the fly incurred about 100 milliseconds only for computing the distance. So and this was not possible at Flipkart scale. So what we were exploring is there a way where we can do a offline computation for this? Now, offline computation, you would say, for so many let longs, right? It is not at the pin code level. It's for so many let longs. How we would be able to do it, right? So what we thought of is there a way where we can somehow get a representative let long for a group of let longs, right? So instead of computing for all the let longs across India, we would compute for a representative let longs, and that distance to that let long would provide us the approximate distance for the let longs surrounding it. And that's where we started dividing the polygons into hexes. So what we did was, an entire globe is divided into fixed set of hexes, which are hexagons, and these hexagons are nothing but statically provided at various resolutions. So the resolutions can range from, say, 0 to 15 based on the library, right? We used Uber S3 library, which provides 0 to 15 resolution. The 0th is the most zoomed out version, where a hex can cover as big as half of India, while 15th is the most granular resolution, which can be as small as this particular hall area, right? So based on few experiments which we did, we were able to go to resolution 10, which is the hexagon of length 75 meters and area of around 220 by 220 meters square. Which is coming to 0.015 kilometers square. So by creating hexagons for this, we were sure that for a representative let long within this hex, any nearby let long would be approximately at the same distance, right? So what we did was, for each of the hexagons, we get a representative let long, and this representative let long would now for us give the distance for every location of the customer. So let's say there are two customers A and B. For these two hexagons, we will get the representative let long and store the distance from that dark store to that particular hexagon, and return and store the distance in meters in our aerospike store. So so this how we did it, right? Sorry. Huh. So this is the final approach, combining both the approaches, right? The first approach is dividing the entire polygon, the polygon which we drew in the first step for customizability. That polygon is divided into fixed set of hexes. Those hex has, each of the hex has the hex ID associated with. Here the hex ID is, let's say, 8608 B4 V0, right? This hex ID now for our use case, on an average, a polygon is divided into roughly about 2000 odd hexagons. So what we do is we store we offline compute this distance from a dark store let long to all the representative let longs, which are about 2000, and store it into our aerospike store. So now whenever a request comes, this is the O of 1 lookup to directly get the distance. We directly do a lookup of average speed for that particular dark store from the first step, and just compute the SLA quickly, right? So combining all these two steps, what we get is the ETA computation, which is a function of stress vector, speed of the rider, and the distance. All these three are O of 1 lookup from our data store, which we are able to do within few milliseconds. So for every request, we don't have to do complex traffic computation. We don't have to do computation of the distance. We are able to exactly compute what is the ETA for a customer whenever it lands on the minutes homepage, right? So covering this end to end. So yeah, so this rider service and this hex distance computation are the two offline processes. So rider service integrates with the dark store, our logistic partners, and get the rider information and stores into the rider store. This rider store is responsible for storing average speed, the rider information, how many riders are available, including which will help us to compute the stress vector. This hex computation is done every time a polygon is updated. So whenever a dark store is onboarded for the first time, this polygon's updates are very frequent based on the on-ground feedbacks. Once it is stable, these updates are not frequent. But even if it is frequent, for all the updates, we are able to compute this hex distance and store it into our polygon store. What this polygon store stores is the aerospike cluster, which I showed, which is the dark store ID to the hex ID and the distance in meters. So now whenever a customer lands into the Flipkart page, we first do the eligibility check using the point-in polygon check using Lucian spatial library. This library gives us whether a customer is eligible or not. If it is eligible, customer will see a minutes tab on their homepage. And once a customer clicks on that minutes tab at the product, there are serviceability check which is done. This serviceability check does nothing but directly get the data from for that particular dark store from the rider service and from the polygon store, and compute the delivery SLA. This delivery SLA would add further thresholds to this, like whether the ETA is within the threshold or not. Apart from that, after getting delivery SLA, we would fetch the apart from delivery SLA, we would also fetch the dark store details. Dark store details would provide us whether the dark store is operational at this particular time, and whether any particular type of items are being serviceable at this particular time, right? So there is the end-to-end flow where a customer, as soon as it lands, we are able to do quick lookup, give the accurate delivery time to the customer, right? So coming to the latencies part. Yeah. So there are two types of process, as I mentioned. First is the offline processing. Offline processing is basically computing the distance for each of the dark store, which means that we are able to compute, do parallel computation and do that computation within a minute, and store it into our data store. Apart from that, the rider refresh jobs generally happens every 60 seconds, and we are doing this for 150 plus dark stores. Based on this offline computation, whenever a request comes for this particular dark store, we first do a minute check. That is roughly about 80,000 QPS, but we are able to, given that it is no network call, we are able to index it. we are storing it in the we are able to compute it in 5 milliseconds. Once the eligibility check has been done for SLA computation as well, given that those are pointed lookups, we are the only thing which we need to do is for a let long get the representative hex ID. Which is also in memory, which we are able to do it within 5 milliseconds. When the hex ID is available, we are just doing a O1 lookup from our Aerospike cluster to get the dark store to the hex ID distance. And once the distance is available, we compute the SLA and return back the result. This entire thing happens within 15 milliseconds latency, right? So these are some of the NFR angles to this. There are various, obviously, continuous improvements going on in this. Analytics team is continuously monitoring what is the delivery time given to the customer during order placement versus what was the actual delivery time. This helps us in fine-tuning the stress factors, fine-tuning various other parameters, as well as the graph upward tuning parameters, right? Apart from the analytics, there is a stress tuning which is being done, and apart from that, there are lot many points which are not systematically in control, which are on ground, very unpredictable, right? Like say a rider which is coming back from after a delivery to the dark store can say wait, can start talking on phone and doesn't come to dark store, right? There are various, the vehicle gets breakdown. There are various parameters due to which the pickup time gets delayed, which will impact our computed distance, right? So that's where we are getting this data continuously and creating a model out of this where we can predictively identify that what can be the pickup time for any dark store that would include in the stress vector. So yeah, I guess that's it. Thank you. So yeah, any questions?
How are you storing the average speed of the rider? I mean, that you compute from your previous.
So that we get from the logistic partner. So logistic partner has the average speed for all the orders they delivered, and we
Okay.
directly get the average speed from our logistic partner and store it into our Aerospike store.
So do you have a cold start problem there because when it's onboarded first time?
Yeah, onboard first time for that particular area, we would be having some logical, say 20 kilometer per hour speed. We do that default, and based on then post that, based on the feedback, we are able to update that average speed.
Okay, fair enough. Okay, can't we get this data from maybe we can source this? I mean, even from Google, we can buy it one time. What is the average speed of a two-wheeler in this area at this time for a week? I mean, sampled for a week.
Correct, but then we thought it would be easier to directly get it from the current
partner.
orders. Yeah, correct. Okay, because it is the real-time view based on the current orders which are getting delivered. So.
Fair enough.